Okay, now we will continue with our last example, example 3. So verify that the differential equation is homogeneous, then find the general solution. If given y1 equal to 2, then find the particular solution. So I will write here, you apply the homogeneity test. So we have f lambda x, lambda y is equal to lambda y square minus 2 lambda x, lambda y divided by lambda x square minus 2 lambda x, lambda y. And then you expand first before you simplify. So remember, you use the index law to expand your function, especially for lambda y square and also lambda x square. Okay, now as you can see, for all functions, for these 4 functions, they have lambda square. So you can factorize lambda square from numerator and also the denominator. Now you can eliminate lambda square and lambda square. Then your function is equal to the original form of fxy. So we can conclude that it is a homogeneous equation. Now, we're going to proceed with the second step. So you substitute y equal to vx and dy over dx equal to v plus x dv over dx. So this is the equation. Is it plus or minus? Minus 2x square, 2xy. So again, you just repeat the same step, substitute y and also dy over dx. Then you simplify function on the right hand side. Where we can see that you can factorize v square from our fraction. So x square divided by x square, you will get equal to 1. So this is your function after you simplify. And don't forget, now you have to rearrange v make sure that V, you bring it to the right hand side. And you try to simplify the right hand side function. You multiply with fraction 1 minus 2v to make sure that they have the same denominator, and your function become only one fraction, so that it will be easier for you to separate your function. So you expand and simplify, you will get 3v squared minus 3v over 1 minus 2v. So similar with the previous example, you can just leave your answer like this on the right hand side, or maybe you can try to factorize out 3. So we have v squared minus v over 1 minus 2v. So after you simplify, don't forget to separate your function. So we have 1 minus 2v over v squared minus v dv equal to 3 over x dx. Okay, right now, after that, I will just write it over here. You can just integrate both sides of your function. For the function on the right hand side, you integrate, you will get 3 ln x plus c. For the function on your left hand side, again, you have to use techniques of integration, substitution method. Actually, to solve this one, you can either use substitution method or partial fraction, but I will show you how to use substitution method because it's easier. Remember, you have to choose u. If you have a fraction, then u comes from the denominator, where u is equal to v squared minus v. Then du over dv is equal to 2v minus 1. Now you check your fraction, make sure you have the same function v and also constant 1. So actually we almost get the same equation. This one is 1 minus 2v, this one is 2v minus 1. You will get the same equation if you factorize out negative. So we get negative 1 minus 2v. This is du over dv. So you can just rearrange. You will get du over negative 1 minus 2v equal to dv. So you're going to use these two functions, u and also dv. So 1 minus 2v over u, dv is du over negative 1 minus 2v. And then you can simplify. So 1 minus 2v divided by 1 minus 2v, we get equal to 1. So what's left on the left hand side is negative 1 over u du equal to 3 ln x plus c. Now you can integrate your function. Negative ln u equal to 3 ln x plus c. So similar with exercise or example 2, you can rearrange in order to simplify your function. So you will get negative c equal to 3 ln x plus ln u. And then negative c is equal to ln x to the power of 3 plus ln u. If you find it's confusing, you can just refer example 2. So I already show you how to use properties of ln to simplify. So you combine or you simplify, you will get x to the power of 3u equal to negative c. And then you multiply both sides with negative with exponential function in order to eliminate ln. So I will write u x cubed. It seems nice like this. So you can just let any constant, let's say a, equal to negative c, exponent negative c, and then exponent ln is equal to 1, you will get u x to the power of 3 equal to a. Okay, now you substitute back u into our solution. So you will get v square minus v x to the power of 3 equal to a. Okay, now finally you substitute v equal to y over x into our solution. So you will get y square over x square minus y over x times x to the power of 3 equal to a. So you can simplify. So try to make the denominator for these functions similar. You multiply with x, you will get y square minus xy divided by x square multiply with x to the power of 3 equal to a. Now you can just eliminate x cubed divided by x square, you will get x. And then you can just leave your answer like this, y square minus xy x equal to a. So this is our general solution. If you want to multiply x inside your bracket also can. It doesn't matter. So this is the general solution. Remember, the question asks you to find the particular solution. So you need to find the particular solution because a condition is given at x equal to 1, y equal to 2. So x equal to 1, y equal to 2. So you substitute these two values in order to find a. So you have 2 square minus 1 times 2 multiply with x multiply with 1 equal to a. So 4 minus 2 is equal to 2. So a is equal to 2. Therefore, the particular solution is y square minus xy multiply with x equal to 2. So we can see that after you substitute the conditions or value of x and y, we don't have a anymore because you can already obtain a where a is equal to 2, then you will get the particular solution. So this is how you solve you find the particular solution for a homogeneous equation. If you have any questions, you can just ask me during our sync class on Friday, or you can just text me personally. Thank you so much. Assalamualaikum and good night.